Okay, good morning to everyone.
Good morning, sir.
Today we will see some. In previous classes we have also seen that some recurrence relation example. So today we'll extend that and I will show some other recurrence relations example. Some other recurrence relations example today I will see. So first you can see this is another example of a recurrence relation. In this recurrence relation, you can see that this is a functions. This functions is written in a C function. Now, in this function, there is a test method, and this test method or a function is taking a input n, and if n greater than equal to 0, then a loop will be executed, and this loop is printing the value of the n. Number of times the loop will be executed, the value will be printed. And this function is calling itself again. That's why it is again written test n minus 1. That is, this function is calling itself. Now, so how this we can from this, so we already in previous classes we have already shown that we can use the two types. We can using two types we can find its recurrence relation. To solve this problem we can find through the recursive tree or a tracing tree, and after that we can solve it using a recurrence relation solving substitution method. So these two types we can solve the recurrence relation. So now if first we can calculate the total time taken by this algorithm. Now you see this total time taken by this algorithm is Tn. That's why this void test intent. This is the total algorithm. So the total time of this algorithm is taken Tn time. Now we know that is this condition is, this is a condition, and this condition is taking one input of time. Now in frequency count method, we have seen that for executing a loop, if the loop is n times, then the loop will be executed n plus 1 time. In frequency count method, I have shown that the loop will be executed n plus 1 time. And the statement that is present inside the loop, the statement which is present inside the loop will be executed n times, but the loop will be executed n plus 1 times. And our this function is calling itself. So this is the test n minus 1. That means the total time is t n minus 1. So we can say Tn is the total time of this algorithm. So Tn is equal to this whole. This whole means 1 plus n minus n plus 1 plus n plus Tn minus 1. This will be equal to Tn because Tn is the whole time. So that's why we adding these values, we can say that Tn equal to Tn minus 1, then plus this nn2, 2n plus 2. So the total time is plus 2n plus 2. That means Tn equal to Tn minus 1 plus 2n plus 2. This is the total time. Now you see 2n plus 2. This is like a polynomial form. This is like a polynomial form. If you remember in frequency count method, I have shown that if there is a polynomial form, then we take the highest order of n. We only take the highest order of n and omit the other values. Here, same as that, here you can see 2n plus 2, we can simply write as n because as it is the order of n. In the polynomial value, in case of frequency count method, I have shown that if there is a polynomial value, we are taking the highest value of the n. We are taking the highest value of the n and simply write that as the order of n. We are doing that. So 2n plus 2, 2n plus 2, it can be simply written as, because n has the highest value as a n, so we can simply write that as an n. Now that's why I am not taking, in the previous example I have shown that I am not taking the values of this condition. This condition value I have not taken in the previous example, which I have shown, because it is not value, because it will be again order of n. That's why this value is not so much important. You can take that, but it is not so much important because you have to make in this form. The formula we have to make in this form. That's why here you can see that it is +2, but there is no value of +2. You can write that, but you have to make the formula in the order of n form or the order of any order of in n. So you have to make in that form. That's why there I have omitted the value, taking the value of uh, condition statement in the previous class, which the example I have shown. That's why I have not taken the value. Here you can see if the total function takes tn equal to tn minus 1 plus n. Okay, so that's why that's reason I have omitting the value. Now our functions became tn equal to tn minus 1 plus n. Now you know that our recurrence relation will become tn equal to, if n equal to 0, if our n is equal to 0, then this if statement will not be executed. So we can say that if t equal to 0, then it will take only, because it is only checking one time if condition. This if condition will not execute, but if it is checked one time, that is 0 less than equal to 0. So that's why the if statement will not execute. So for this we assume that we require one amount of time. That's why here, if n equal to 0, we can say that one time required. And if n greater than equal to 0, it will execute tn minus 1 plus n. So that's how we can create the recurrence relation. Now, after creating recurrence relation, we can show that after creating the recurrence relation, what we will do after creating the recurrence relation, we will find it through a first step. We'll find it through the recursive tree. We'll find it with a recursive tree. Now in this recursive tree, if you can take the function, what this recursive tree is doing, that it will take, if this is, it will take n value, then the loop will be executed n times, and then it will call the function tn minus 1. Then when it will take n minus 1, first time it will print n minus 1, then it will again execute itself. So tn minus 2. After tn minus 2, if it is take n minus 2, it will print first n minus 2 and it will call itself again. So that's how the recurrence relation will go on. Now, what is our main motto? Our main motto is to become the tn functions to 0. Because if 0, then the recurrence relation will be stopped. Or we can say the total recurrence relation is complete. So because if it will be equal to 0, then the recurrence relation will be stopped. So our main motto is to become it 0. If it is 0, then we can say that our recurrence relation is completed. So that's why after this statement, what we will do, it will continues, and then continues, it will one time it will become t2, then 2 will be printed and it will be call itself t1, and after 1 will be printed and it will be called t0. When the t0 will be called, that means our total functions is completed, because 0 less than greater than equal to 0, this will not execute. So our recurrence relation will be completed. So always think, when you are doing some recursive tree, then always think your main motto is to become it as 0. If it becomes 0, then it will be complete its execution. Our functions will complete its execution. So that's how the recurrence tree will be looked like. First it will take tn, and then n will be printed and it will be again call itself. That's why tn minus 1. Then n minus 1 will be printed and it will call tn minus 2. Then n minus 2 will be printed and it will be called tn minus 3. And after that, we continues these steps, and somehow it will came that t value, the n value is go to 2, and 2 will be printed and it will be called t one time. Then 1 will be printed and it will be called t0. When it will be t0, the total execution time or the execution of the functions will be completed. Now, how these values are present. Now you say that when it is taking tn, it is printing n value. So that means n amount of time. So this function is taking, we can say this, assume that this function is taking n times. If next time it is tn minus 1, so it will say that it is taking n minus 1 time. Next time tn minus 2, that means it is printing n minus 2, that is takes n minus 2. After that tn minus 3, so it will take n minus 3 time, and when it will t2, it will takes 2 time. When t1, that means 1 is printing, that it will take 1 time, and t0 we can say that this time it is not printing anything when it is t0, so it will be 0. So now if we add this total time, 0 plus 1 plus 2, 2 plus n minus 3 plus n minus 2 plus n minus 1 plus n, then what it will become? See what it will become? It is the sum of the natural numbers. It is the sum of the natural numbers. Then what is the formula of the sum of natural numbers? It is n plus 1 by 2. This is the sum of n terms. This is the formula of the sum of n terms. So that's why it is written n plus 1 by 2. And that means if we simplify it, it will become n square plus n by 2. If we simplify it, then it will become n square plus n by 2. Now, what is the highest value? N highest value is n square. That means it will be order of n square. Now, what we will write? We can write theta of n square, or we can say it is of big O n square. We can write anything. I have written n square, theta of n square. You can write big O of n square also, because I have shown that this is the upper bound. N square is in the upper bound of a function. So upper bound means big O. We can write it with a big O. And if we can also write it in the average cases also, that is theta of n square, we can write it also. So that's how our Tn, total time of these functions, will be the order of n square, or theta of n square, or we can say big O of n square. It is clear that how we find this through recursive tree, how we find the total time. Clear to everyone? Okay.
Yes, sir.
So that's how our, through recursive tree, we can find it through we can find it like that. Now this is the recursive tree finding. Then how we can solve this recurrence relation using substitution method? If we solve this problem using substitution method, then it will look like this. If we solve this problem using substitution method. Now in case of substitution method, you see, first, what is our main function? Tn equal to Tn minus 1 plus n. This is the total functions of our total we get, that Tn equal to Tn minus 1 plus n. Now, to find the value of Tn, we have to first find the value of Tn minus 1. Then how we can find the Tn minus 1 value? We will substitute, in case of n, we will substitute Tn minus 1. So if we substitute the value n minus 1 in case of n, then it will become, the functions will become Tn minus 1 equal to this, in here, this will be n minus 1. So n minus 1 minus 1. That means Tn minus 2 plus n minus 1. So what Tn minus 1 will become Tn minus 2 plus n minus 1. That's how this substitution is made. In case of equal to Tn, in case of Tn minus 1, we put the value which we get, this value which we are getting after solving, we put that Tn minus 2 plus n minus 1. See, we put the value Tn in case of Tn minus 1, that is Tn minus 2 plus n minus 1. Then what will be plus n. So now what we will have to do, it will become Tn minus 2 plus n minus 1 plus n. Now, when you will solve this type of problem, one thing you should remember, please do not add this, terms. That means you can say that it is plus n square, plus 2n minus 1. You can say that, but do not add these terms. You can only put like this way, n minus 1 plus n, because it will easy to make the when you will put the solutions, or when you will put the formula, it will be easy for you. Otherwise, if you add the terms, then it will become difficult for you to find the formula of it. So always remember, do not add these terms. Always put it in the exact form which you get. So that's why you can see I have not added it. So that's why that our total functions will become tn minus 2 plus n minus 1 plus n. So we can say this is the after this step, it is we have written it 2. Now we have to substitute this tn minus 2. So when substitute tn minus 2, so what will it become? In case of n, we put it n minus 2, that it will become tn minus 2 equal to, in case of n, we put n minus 2, then what will become tn minus 2 minus 1. That means tn minus 3. And in case of n, you will put n minus 2, it will become n minus 3. So we'll, in case of tn minus 2, we'll substitute this value. So n minus 2 substitution, it will become tn minus 3 plus n minus 2, then plus n minus 1 plus n. So the order, the functions of the order will become tn minus 3 plus n minus 2 plus n minus 1 plus n. So after performing this, we can say that we can continue up to k steps. So after continue up to k steps, now what these functions will become? Now continue this up to k steps. What functions will it become? Then if continue these steps with k times, then it will become tn. In case of this, it will be t n minus k. Now you see it is 3, the value is 2, then the value is 1. So if in case we can say if we put k, then this value will become k minus 1. This will become k minus 2. This is 1. If we put, in case of 3, if we put k, then this value will be 2, will be k minus 1. This 1 will become k minus 2. So that's how you can see tn equal to tn minus k, then plus n minus k minus 1 plus n minus k minus 2 to n plus 1 plus n. So after continue up to k steps, this will become. So if we assume our main, which I have already told that our main motto is to become this T0, because if this will be T0, then it will be completed. So if this is T0, then our functions will be, we can say that our recurrence relation will be completed. So for this, what you have to do, you have to put n minus k, or assume n minus k equal to 0. Because if this, if we able to making this term equal to 0, then which this will be become T0, or our recurrence relation will be completed. So our main motto is to make our recurrence relation completed. So that's why you have to put this term equal to 0. And that's why assume n equal to k, n equal to k 0. That's why you can see that n minus k equal to 0. And after this, it will become n equal to k. That means k equal to n. Now, if we put this value in our functions, now if we put this value in our functions will become tn equal to tn minus, in case of k, because we find that k equal to n. That's why in case of k, we put the value of n. Then it will become n minus 1, n minus n plus 1, then it will become n minus n plus 2, and 2 up to plus n minus 1 plus n. So it will become T0, and this will become 1 plus 2 plus 3 to n plus n minus 1 plus n minus 1 plus n. So that means, what is this? This is the sum of m terms, means sum of n natural numbers. So T0, we have know that T0 value, this is 1 plus n, this will be the sum of n terms, or the sum of n natural numbers. That's why n plus 1 by 2. That means, now how we can say? We can say that the highest order, if we simplify it, it will become n square plus n by 2. That means what will be the highest order of n? Highest order of n is n square. So we can say that it will be on the order of n square, or the theta of n square, or in the big O of n square. So this is the way to solve a recurrence relation using substitution method. First, always try to use the first, if you want to solve it, always try to first use the recursive tree, and after using of the recursive tree result and the recurrence relation solving using substitution method, the two result will be same. If the two result will be different, then there is a problem in your solving. So always remind, or always try to solve this like that. First, you have to use the recursive relation using tracing tree or recursive tree, and then you solve the recurrence relation using a substitution method, and check that the both result is same or not. If the both result is same, and then you can get the desired result. Okay, so clear how this substitution method through which we can solve the recurrence relation?
Yes, sir.
Or anyone has any question? Or anyone? Anyone has any question?
No, sir.
Okay. And one thing also, remember that time that this, for solving the recurrence relation using substitution method or using the tracing tree, you should be clear in some mathematics. Like this type of problem will came, that in mathematics some GP series formula or the sum of n terms formula, these are mainly used. So this mathematical type you should be cleared. Otherwise, you cannot able to solve the recurrence relation. Okay, so how you have to solve this, or how in the mathematics you have already see this, that the how progression series, GP series, then AP series, this will be used in the solving this recurrence relation. So you should be clear on that. And mainly in the recurrence relation, you have to mainly how solve it. Sometimes there is a main thing is you have to practice it, because I will show some type, but in the exam you will, it is main thing that you will get another recurrence relation also. But first, the recurrence relation time calculation will be solved, then you can solve the problem. So first, how this time calculation should be done are, you have to very much clear of that, because otherwise you cannot solve this. So how can this problem, because in exam there can be other functions also. These functions, it is not based on that which I have shown, these functions will be given. There may be other functions will be given. You have to find that time, and after the finding that time, you solve the problem using the recurrence relation substitution method, or using the recurrence relation with the recursive tree. So you should practice it. Practice it with other example also. Then it will be clear to you. Okay. So this is another type. Now I will show another type also. Now this is a decreasing functions. So I will show another type also. Now in this type you can see, this is another example. This is another example where you can see that our loop is executed. Our loop is executed for I equal to 1, I less than n, I equal to I into 2. And the value of the I is printed. And the function is calling itself. Now, you can see I have omit for calculating this loop, and this function's time are not calculated. Because if we omit this, this will be not problem also. Because when you are solving this problem, you can see when I solve this problem, the total time is Tn equal to Tn minus 1 plus n. So in the statement which is present inside the loop, I am mainly considering that mainly considering that because Tn equal to Tn minus 1 plus n. So the statement which is present inside the loop, we are considering that only. That so if we omit this two value, it will not make our so much difference. You can see that the last value which we have get is Tn equal to Tn minus 1 plus n. So mainly this three values, the total time, the recurrence time, and the statement present inside the loop, the value will be calculated or the value will be taken. So that's why if we omit these two values, there is not so much problem. Okay, so here in this case also, you can see that's why I have omitted this, that I have not taken the value of the condition and the executing of the loop, the number of times the loop is executed. I have omitted that. So I have only taken that the total time is Tn. And this statement, now if we in frequency state method, frequency count method, I have shown that if this type of loop is executed, this type of loop, mainly the statement present inside this type of loop is executed log n times. Mainly if for I equal to 1, I less than n, and then I into 2, like that, if the loop looks like that, then the statement present inside the loop will be executed log n. Now, in this case, I have not shown it, but you can write also that if this statement, it will be log n plus 1, and this statement will be 1 times, because it is a normal statement, so it will take one amount of time, and the loop, we know that loop is executed n plus 1 time, so it will be log n plus 1. But I have not taken that, mainly in the case of if we take the statement present inside the loop, your work will be done. So that's why I have omitted that. In case of previous example also, that there is, you can see the difference that the main, at last we are getting this value, that Tn equal to Tn minus 1 plus n. Means this, and what is the n? N is the statement present inside the loop. So you can getting that. You are mainly getting that. So that's why I have not taken it. Now what will it become? It will become Tn equal to Tn minus 1 plus log n. And we know that if n equal to 0, it will be 1. And otherwise, if n greater than equal to 0, it will be Tn minus 1 plus log n. So what will be our recursive tree looks like? Our recursive tree will be looks like that it will, if it will be Tn, then log n will be printed and Tn minus 1 time calls will be generated. Then log n minus 1 will be printed, Tn minus 2 calls will be generated. Then n minus log n minus 2 will be printed and the calls will be generated Tn minus 3. So that's how you can up to go to 0th terms. Then T2 log 2 and it will be executed. It will be, the call will be T1 by T1. Then log 1 will be printed and it will be T0. So that's time our total execution of this loop is stopped. So now if we takes what amount of time it will require, it will require Tn will require log n time. This will require log n minus 1 time. This will require log n minus 2 time. This will require log n minus 3 time. 2, this will require log 2. This will require log 1 and it will be 0. So now if we solve this problem, that means now it will become log n plus log n minus 1. If we total calculate the value, it will be our log n minus 1, then log n minus 2 dot plus 2 log 2. This will be log 2, this will be log 1. So it will continue up to that time. And if we, how we can solve this? If we take the log common, if we take the log common, it will be n into n minus 1, 2 into 2 into 1. Now what is this? 1 into 2 into n minus 1 into n. This is the factorial type. This is the mainly the factorial. So that's why we will get log n factorial. And log n factorial means it will be n log n, order of n log n. If you solve it with mathematics, it will, you can see it will be of n log n. So our order, in which order it will be shown? This order we will show in the order of n log n. So now if we use or solve it using the substitution method, you can use the substitution method. Then what is our motto? our motto is to become it 0. And get the result, we have to solve the problem. To get this result, we have to solve the Tn minus 1. So n minus 1, the substitution method is used. So Tn minus 1 will become, if we place this in place of n, if we place this in place of n, then what will Tn minus 1? It will become Tn minus 1 minus 1. That's why Tn minus 2. And in case of n log n case, the n will be substituted and it will become log n minus 2. So that's how you can see that it is substituted and it looks like that. Log n minus 2 plus log n minus 1 plus log n. Then this value should be substituted. If this value should be substituted, then it will look like this. Tn minus 2 equal to Tn minus 3 plus log n minus 2. So Tn minus 3 plus log n minus 2 plus log n minus 1, then plus log n. So it will become Tn minus 3 log n minus 2 plus log n minus 1 plus log n. Same as that, if we substitute it again, it will become Tn minus 4 plus log n minus 3 plus log n minus 2 plus log n minus 1 plus log n. And if it will continue up to k times, then what will become it? If in case of 4, it will be become k, this will become kn minus 1, this will become kn minus 2, k2, sorry. In this case, this will be k, this will be k minus 1, this will be k minus 2, this will be k minus 3. So that's why you can see Tn minus k plus log n minus k minus 1 plus log n minus k minus 2 plus log n minus k minus 3, and up to how it will, how much time it will continue, or up to how terms it will be continued to log n plus 1 plus log n. Now, if we put this, then this term should become 0. So n minus k equal to 0. That means k equal to n. And we will substitute it. So in case of this, it will become Tn equal to T0 plus, in case of n, it will be n minus n plus 1. That means log 1. This will become log 2. This will become log 3, 2 log n minus 1 plus n. And if we take this, it will become n factorial. So n factorial means it will be order of n log n. Clear? So that's how it can be solved. So the two examples which I have shown today, it is clear?
Yes, sir.
Yes, sir.
Okay. Now I will say that if in exam there is an objective is given, like you have an objective is given, then how can you solve it? If you solve like this and try to get result, then it will be your 10 minutes or 15 minutes will be gone for an objective. Then the simplest trick to solve this problem for an objective method is, if like that, our function is like that given, that Tn equal to Tn minus 1 plus n, then from this we'll directly write that it will be order of n, because there is no n, there is not n, so only this n is present. So from that square, you can directly write these functions will be order of n. This is the simplest trick for solving an objective. If there is Tn equal to Tn minus 1 plus n, then from there you can directly write this is, there is an n, there is an n. So our n value will be n square. It will be order of n square. If you can see that if it is Tn minus 1 plus log n, like that, then directly write this is n, this is log n. So n log n. You can directly write from that. So this is the simplest trick. But if in exam you have to given to solve this problem in the and there is 5 marks or 10 marks, then you have to solve it total like this. But in case of objective, this is the trick to write an order of a function. Write an order of a function. You simply put the value present. You will calculate or multiply these two values, this last term and the values that is present in the tn part and the value that is present on this part. So you can see directly from here, I can say tn minus 1 plus log n. That means this is a n and this is log n. So our functions will become order of n log n. If tn equal to tn minus 2 plus 1, then what it will become? It will become order of n. If there is tn minus 100 plus n, then what will be the order? The order will be the n square. So this is the simplest trick to solve a recurrence relation. And when you are doing some objective, then write like that. Okay. It is clear?
Yes, sir.
Okay. So this is another type. You can solve it. You can solve it. This is another recurrence relation. Like this, same as that, you have to first you have to calculate the time, and after this time, there is a time, and after this time, we will equal that tn equal to tn minus 2. In this algorithm, you are seeing that 2 times the function is calling itself. So that's why the total time is the tn, and we are considering the statement. That's why this is require 1 unit of time, and this is again, this function is calling itself twice. So that's why you can see tn minus 1, tn minus 1, and our total time will become tn equal to 2tn minus 1 plus 1. You can see now, after this, you have to solve this problem using recurrence relation. So I think you can solve it. Tn equal to 2tn minus 1 plus 2, first using the recursive tree and then using the